Introduction to chicken farming, historical context. Domestication of chickens, when and where it started. Early uses, meat, eggs, and religious or cultural significance. Traditional chicken farming practices, free-range systems, small-scale, family-owned operations. Role in rural economies and subsistence farming. The transition to commercial farming, population growth and demand. Increasing global population and demand for affordable protein. Economic and societal factors driving commercialization. Industrial revolution and its influence, mechanization of farming processes. The rise of agroscience and selective breeding. Introduction of hybrid breeds, development of faster-growing broilers and high-laying hens. Impact on traditional breeds and biodiversity. The rise of mega-chicken factories, defining chicken mega-factories. Characteristics, large-scale operations, confined spaces, automation. Differences from traditional methods. Technological advances, feed optimization and automation. Temperature-controlled environments and biosecurity measures. Economic incentives. Cost reductions through economies of scale. Integration of supply chains, impacts of mega-factories. Environmental impacts, waste management challenges. Contribution to deforestation and carbon footprint. Ethical concerns, animal welfare, overcrowding, beak trimming, and life cycle management. Role of activism and regulations. Economic effects, accessibility of affordable poultry products. Impact on small-scale farmers. Health and food safety, disease management. Rise of antibiotic use and resistance. Biosecurity measures and challenges. Quality control, standards for meat and egg production. Concerns over contamination, for example, Salmonella, E. coli. Case studies, mega chicken farms around the world. USA, Tyson Foods and Purdue. China and Brazil, leading exporters. India and Africa, emerging poultry industries. Successes and controversies, innovations in farming. Scandals and public outcry. Future of chicken farming, technological innovations. Artificial intelligence and IoT in farming. Genetic engineering for disease resistance. Sustainable practices, organic farming and free-range systems revisited. Integrating renewable energy and reducing waste. Consumer trends, demand for humane practices and plant-based alternatives. Certification systems, for example, organic, cage-free. Conclusion, reflection on the transformation of chicken farming. Balancing efficiency with ethics and sustainability. Role of governments, corporations, and consumers. Historical context, chicken farming dates back thousands of years, originating in Southeast Asia. Chickens Gallus domesticus are descendants of wild jungle fowl, domesticated around 8,000 years ago. Early societies kept chickens primarily for cockfighting, religious rituals, and limited consumption of eggs and meat. With time, chickens became a crucial part of agrarian systems. Ancient Egyptians, Greeks, and Romans began selectively breeding chickens for specific traits like increased egg production. In medieval Europe, chickens became common in peasant households due to their adaptability, ease of care, and ability to provide consistent food sources. Traditional chicken farming practices in pre-industrial societies, chicken farming was largely small-scale. Free-range systems, chickens roamed freely, foraging for insects and grains. Diet and care, they were fed kitchen scraps and had minimal human intervention. Seasonal production. Egg and meat production was seasonal, with little surplus for trade. Farmers raised chickens alongside other livestock, using natural methods for pest control and manure for fertilization. The scale was sustainable but limited. The transition to commercial farming, population growth, and protein demand. The global population explosion in the 19th and 20th centuries increased the demand for affordable protein sources. Chickens emerged as an ideal solution due to short reproduction cycles, high feed conversion efficiency, versatility in diets and farming systems, The impact of the Industrial Revolution. Mechanization during the Industrial Revolution revolutionized agriculture. Key developments included introduction of machinery, automated feeders, waterers, and temperature controls. Advances in feed science. Formulated feeds ensured balanced nutrition, boosting growth rates. Selective breeding. Farmers began breeding chickens for specific traits like fast-growing broilers or high-laying hens. The birth of poultry as an industry. By the mid-20th century, the poultry industry underwent significant transformations. Chickens transitioned from backyard farming to specialized production. Hatcheries, feed mills, and processing plants became part of an integrated supply chain. Governments supported poultry farming to address food security. The rise of mega chicken factories. Defining chicken mega factories. Chicken megafactories, or industrial poultry farms, are large-scale operations designed to maximize efficiency and output. Characteristics include housing thousands or even millions of birds in confined spaces, relying on automation for feeding, watering, and waste management, employing vertical integration to control breeding, feeding, and distribution. Technological advancements. Technological innovations have enabled megafactories to meet rising demands. Climate control. Advanced systems maintain optimal temperatures and humidity. Feed automation. Computerized systems monitor feed distribution and consumption. Biosecurity protocols. Measures like air filtration, foot baths, and controlled access reduce disease outbreaks. Economic incentives. Large-scale poultry farming thrives due to cost reduction. Bulk purchasing of feed, medications, and equipment lowers costs. Market demand. Urbanization and fast food chains increase demand for uniform, affordable chicken products. Global trade. Countries like the USA and Brazil dominate exports, meeting global demand. Impacts of megafactories. Environmental impacts. Mega chicken factories have significant ecological footprints. Waste generation. A single factory can produce tons of waste daily, leading to water pollution. Deforestation. Land clearing for feed crops like soy and corn contributes to habitat loss. Greenhouse gas emissions. Emissions from feed production, manure management, and transportation contribute to climate change. Ethical concerns. Ethical debates surround the treatment of chickens in industrial farms. Overcrowding. Chickens often live in cramped cages or barns with little room to move. Physical modifications. Practices like debeaking prevent injuries but raise ethical questions. Short lifespans. Broilers are slaughtered within weeks and layers are culled when productivity declines. Economic effects. The rise of megafactories has both positive and negative economic implications. Affordable products. Factory farming reduces costs, making chicken accessible to low-income populations. Impact on small farmers. Traditional farmers struggle to compete, leading to loss of livelihoods and rural decline. Health and food safety. Disease management. The concentration of thousands of birds in confined spaces increases the risk of disease outbreaks. Avian influenza. Virulent strains can spread rapidly. Antibiotic resistance. Overuse of antibiotics in megafactories poses a threat to human health. Quality and safety concerns. Industrial systems aim to ensure consistent quality, but challenges remain. Contamination risks. Improper handling can lead to Salmonella or E. coli outbreaks. Hormones and additives. Public concerns over the use of growth promoters and feed additives. Case studies. USA. Tyson Foods and Purdue. The United States is home to some of the largest poultry companies. Tyson Foods, a pioneer in vertical integration, controlling every step from hatching to processing. Purdue Farms, known for adopting antibiotic-free policies in response to consumer demand. Brazil. A global exporter, Brazil is the world's largest chicken exporter, benefiting from low production costs, favorable climate, and cheap labor. Government support, subsidies, and trade agreements. India and Africa, emerging markets. In developing regions, chicken farming is growing rapidly. Shift from backyard to commercial systems, increased investments in infrastructure and technology. Challenges: balancing modernization with sustainability and cultural preferences.
Future of chicken farming. Technological innovations. Merging technologies are shaping the future. Artificial intelligence (AI), predictive analytics optimize feed and health management. Genetic engineering. CRISPR technology offers potential for disease-resistant breeds. Sustainability initiatives. Poultry industry is exploring eco-friendly practices. Renewable energy, solar-powered farms and waste-to-energy systems. Alternative feeds, reducing reliance on soy and corn through insect-based and algae-based feeds. Changing consumer preferences. Modern consumers demand transparency and ethical practices. Plant-based alternatives. The rise of lab-grown meat and vegan products. Certification labels. Terms like organic, cage-free, and pasture-raised influence buying decisions. Conclusion: the evolution of chicken farming from backyard operations to megafactories reflects humanity's quest for efficiency and affordability. However, this transformation raises critical questions about sustainability, ethics, and health. Balancing industrial progress with ecological and ethical considerations is essential for the future of poultry farming.
Wild jungle fowl. Chickens were first domesticated from the red jungle fowl Gallus native to Southeast Asia. The primary motivation for domestication may have been cockfighting, a popular pastime in ancient cultures before transitioning into a food source. Spread across civilizations. Chickens spread westward via trade routes. By 2000 BCE, they reached the Middle East, and by 1400 BCE, they were in Egypt. Romans introduced systematic breeding in Europe. Early farming practices, subsistence farming. In agrarian societies, chickens were part of a mixed farming system, providing eggs and occasional meat. They helped recycle food waste and contributed to integrated pest management. Cultural and religious significance. Chickens held religious importance in ancient Greece and were central to various myths symbolizing prosperity or sacrifice. Global distribution and variations. Each region developed unique chicken breeds based on local needs. Asia: Silkies for their unique plumage. Europe: Sussex and Leghorns for high productivity. Africa: indigenous breeds adapted to harsh climates. The transition to commercial farming, driving forces behind commercialization. Urbanization. As cities grew, the need for centralized food production increased. Technological advancements. The invention of incubators and mechanized feeders laid the foundation for scaling up operations. Changing diets. The post-World War II era saw chicken surpassing beef in per capita consumption due to affordability and versatility. Scientific breakthroughs in breeding. Cornish cross. This hybrid breed revolutionized the poultry industry. Cornish cross broilers grew faster with larger breasts, catering to consumer preferences for lean meat. Laying hen innovations. Breeds like the white leghorn were optimized to lay 300 eggs annually, compared to 50 to 100 eggs from traditional hens. Establishment of hatcheries. Hatcheries centralized the egg hatching process, improving productivity. By the mid-20th century, hatcheries produced millions of chicks annually, shipped worldwide to meet local demands.
The rise of mega chicken factory structure and operations of mega factory shifting systems. Chickens are often kept in battery cages, small wire enclosures for egg-laying hens, broiler sheds, climate-controlled barns housing thousands of birds, integrated supply chains. Companies own or control all aspects, from breeding to retail, ensuring consistent quality and cost control. Automation. Machines handle feeding, watering, and even egg collection, reducing labor costs but increasing dependency on technology. Workforce in megafactories. Despite automation, thousands are employed in hatcheries, feed mills, and slaughterhouses. However, these jobs often face scrutiny due to low wages and high risks. Economic contributions. Market share. Globally, the poultry industry contributes billions of dollars annually. For example, the U.S. poultry industry generated over $50 billion in 2022. Brazil exported 4.2 million tons of chicken in the same year. Impacts of megafactories. Environmental consequence. Manure management. A single megafarm can produce over 100 tons of manure daily, leading to nitrogen runoff and waterway contamination. Deforestation for feed. Soy cultivation in Brazil, a major chicken feed component, is a leading cause of Amazon deforestation. Energy consumption. Large-scale farms rely heavily on fossil fuels for operation, contributing to greenhouse gas emissions. Animal welfare. Confinement stress. Chickens in overcrowded conditions often exhibit stress behaviors, such as feather pecking. Health complications. Fast-growing broilers suffer from skeletal disorders and heart failure due to their unnatural growth rates. Mortality rates. In poorly managed facilities, up to 5 to 10% of chickens may die prematurely. Public health concerns. Zoonotic diseases. Overcrowding increases the risk of diseases like avian influenza spreading to humans. Antibiotic resistance. Overuse of antibiotics in industrial farms leads to the emergence of drug-resistant bacteria. Health and food. Tibia use in poultry. Growth promoters. Antibiotics are often added to feed to promote faster growth, but their overuse has raised global health alarms. Regulatory changes. Many countries, including the EU and the US, have banned antibiotics for growth promotion, encouraging alternative methods like probiotics. Quality control measures. Hazard analysis in critical control points. A global standard implemented in poultry processing plants to minimize contamination risks. Consumer expectations. Increasing demand for organic and hormone-free products has pushed companies toward transparency.
Case studies. Tyson Foods, industrial scale in the USA. Tyson pioneered vertical integration, controlling every stage from hatcheries to supermarkets. By 2023, it produced over 40 million chickens weekly. Challenges. Tyson has faced lawsuits over worker safety and environmental violations, highlighting the darker side of large-scale farming. China. Rapid growth. China produces over 10 billion chickens annually, driven by domestic demand. Challenges. Outbreaks of avian influenza periodically disrupt production, requiring stringent biosecurity. India, a hybrid approach. India's poultry sector is split between industrial and traditional systems. Small farmers often work under contract farming arrangements with large companies like Venky's. Future of chicken farming. Technological innovations. Robotics. Autonomous robots now manage tasks like manure collection. Data analytics. AI-driven models predict disease outbreaks, allowing proactive interventions. Sustainability efforts. Circular economy models. Some farms recycle waste into biofuel or fertilizer, reducing overall emissions. Alternative protein sources. Companies are researching insect-based feeds to replace environmentally taxing soy and corn. Ethical farming trends. Certifications like Certified Humane and Animal Welfare Approved are gaining traction as consumers demand ethical treatment of animals. Conclusion. The story of chicken farming mirrors the larger narrative of industrial progress, highlighting the tension between efficiency and ethical responsibility. As the industry evolves, stakeholders must address pressing challenges, including sustainability, welfare, and health. The balance between feeding a growing population and preserving the planet's resources will define the future of poultry farming. This expansion is just the beginning. I can provide further breakdowns or flesh out specific parts to achieve the depth needed for a comprehensive 25,000-word document. Let me know which sections or subsections you'd like me to elaborate on.